the warehouse itself is unpredictable. Lighting conditions change. There's vibration here and there. You think that you've built the exact same thing over and over again, but the reality is things happen. Wi-Fi ranges don't always work the same way. There's humidity in some places. There's cold in other places. There's light reflections, those kinds of things. Those really bug robots, right? Robots are not really happy when the environment's not ideal. And so hence why I kind of named my company 10 Things, because it's all about solving those challenges that kind of take us from here I have a robot to here I have something in production that can work repeatedly.
That is Kimate Richards, founder of 10 Things, where he's building the Android operating system of robotics. Kimate has a seasoned history in robotics spanning over 20 years, where he navigated nearly every industry. He has seen hard problems firsthand, from unpredictability of human environments to micro abrasions that cause hardware to fail at scale. Now he's building a platform to overcome these challenges and bring the future of robotics to life. Special thanks to Lightwheel for making this episode possible. This is the Thinking Machine podcast. Now let's dive in. Kimate, thanks for joining the podcast. I'm really excited to have you on this today. We first met at CES, and you gave me a mini tour of what you're building. So, Kimate, thanks for coming on, and welcome.
Thank you. I'm excited to be here.
All right. So, like I always like to start my podcast with doing a little bit of a backstory on you, to give people an idea where you came from, why you may have built what you're building or researching what you're researching. So, Kimate, I know that you have a long, seasoned history of working in robotics, which there's not a lot of people on the planet that do, because that is a very kind of a newly emerging field, I would say. I mean, it was just much smaller back when you started. So I did a little background on you, and it looks like you started by going to college for becoming a mechatronics engineer. Is that correct?
That is correct. I went to start really. I want to start when I think I was 5 years old. My dad took me to see Star Wars for the first time, and that's where I knew if there was going to be anything like a robot, I wanted to be involved in it. And I started writing code at 7 and all those kinds of things like you would need to do. And then, I did go to college for mechatronics. Before that, I went to college for computer science. They all work together, I think. Post that, I didn't really get to work in robotics for, because this is 20 something years ago. Robotics wasn't really a thing unless you went to the automotive industry. So I did a lot of control systems, coding, a lot of PLC work, a lot of roundabout things before I was able to get into robotics, but I got there eventually.
Okay, so did you feel like that helped though? Like, you're not working then straight on robots, but working on these subsystems and all these exponential technologies. Did that help make you more rounded?
100%. I can't even tell you how much that helped me. I was, really just, I've been in every industry. I've been, you name it, I've been there. I've been in, if you name an industry, I can probably remember something that I did in that industry. So,
Oh, wow.
but that did help me for sure. Supply and logistics, certainly hospitality, hotels, finance, you name the industry, I've been in it. Oil and gas, I've done some work pretty much everywhere.
This reminds me of a point. I went to a robotics symposium, I think about 2017, so almost a decade ago. The ending keynote was the head of innovation for HP at the time, and so we had all these students at Oregon State that were there to learn about robotics, and he said that don't just become a roboticist, find sort of passion, some sort of industry that you're into outside robotics, and figure out how to merge those two together, because it gives you a more broad experience, and you can build more application specific robots, right? It was kind of like, well, you can get really good at just building technology, but it should serve a purpose. So if you can become an expert in something or tie your hobby into that, you'll probably build something more important and more interesting. Kind of sounds like that. You got this nice broad experience, and then you can tie that back into what you're building now.
Yeah, yeah. The other thing is I got to see like the end result of where the robot was supposed to go. Um,
Hmm.
so that to me, people don't realize that robotics is really, really hard. But the but if you get focused or hyper focused on just the I want to build the robot, then you forget that it needs to go do a thing. And I think those are the things that people tend to forget. And then also, kind of why I built this company is I want to get to the point where the hard part, where we're kind of alleviating a bit of the hard stuff and we're getting over to the like let's make it do something. And I'm a little critical on the internet because I'll point out that, flipping around and catwalking, that's not what we're trying to do. We're trying to, and that's a good start, but it's not where we're trying to get to.
Yeah, I like you got to take the step back a little bit. That's why I like some of these really highly purpose box companies that are not trying to solve every challenge, but especially today, like if you can solve some really high need challenges, you're gonna get. I feel like you're gonna get a lot further. So it's hard to build that, generalist home robot because like what one thing you need to do, well, you have to do everything. But if you can say, oh, okay, I'm gonna be doing this one task in a warehouse that's high value but also maybe risky for a human to put, you're gonna get a lot further there. And so knowing like what at that warehouse or where at that location that they need solved first, you kind of have that experience then to go, yeah, tackle that first.
Yeah, yeah, no, that you're absolutely right. And working, I worked at Amazon, it's no secret. Working there allowed me to see probably the most complicated robotics deployment in history. Amazon has a million robots plus, right?
Mm-hmm.
And while they're all purpose built, like there's very few multi-purpose robots in the facilities, you get to see why they did exactly what they did and all the challenges that they've overcome,
Hmm.
making sure that the robot can work with people. And so there's just like HR challenge or safety OSHA challenge that you have to solve. Beyond, you also want to do things that speed up the performance of the people and, help people go on and do other things rather than just kind of move packages from left to right. And so I think, learning from that and then seeing other clients doing the same thing, I think it was really important for my career. I've
Hmm.
been to I can't even tell you how many different warehouses with robots in it.
Amazon is a really good example, right? Where they have these really, really complex warehouses, places that you're putting these robots. Is the hardest challenge just the fact that there's so much going on in that warehouse, so many moving parts, or the fact that you have humans on the floor that are unpredictable and messy you have to deal with?
Yeah, it's a little bit of everything. It's so humans are unpredictable. The warehouse itself is unpredictable. Lighting conditions change. There's vibration here and there. You think that you've built the exact same thing over and over again, but the reality is things happen. Wi-Fi ranges don't always work the same way. There's humidity in some places, there's cold in other places, there's light reflections, those kinds of things. Those really bug robots, right? Robots are not really happy when the environment's not ideal.
Hmm.
And so hence, why I kind of named my company 10 Things, because it's all about, solving those challenges that kind of take us from here I have a robot to here I have something in production that can work, repeatedly.
All right. Well, so that's a really good segue into what you are building, 10 things. So when I was at CES, you had described this as the Android operating system for robotics. Is that correct?
Yeah. So at 10 Things, the first thing we're focused on is how to make the developer, roboticist, robotic engineer's life easier, just in general. Like there are things about robotics that are quite difficult. Getting the robot set up to be able to just, pass messages in any way that it's supposed to pass. Certainly getting the robot into the simulator. But more importantly, once it's in simulator, what are you going to do there? And there's a lot of new models and new thinking, new policies, those kinds of things. And what we're really focused on is ensuring that every robot client that we have gets the latest, best in models. We do analysis, doing comparisons between models, those kinds of things. And then we do the sim to real transfer back out. So we do something called sim to real to sim to real, which is It sounds like a lot, but the reality is there's this kind of flywheel that's always
Mhm.
happening. So there's, we're always continuously discovering about the robot, its current behavior, and when I mean the robot, I mean the individual robot. Well, yes, we do things at a fleet macro level of your robots, but down to the individual robots change over time, and I think that's something that companies find out as they deploy is that the robot itself will change, meaning it starts out with this ideal conditions. The motors are brand new, or the bearings are great. It might be a little stiff, and then over time, it goes back to some normal place. I'll stop there because I know I can go on a monologue. So this,
No, no, this is good. And so you're talking about this is how I've been thinking about robots as well, and how we're going to be building the next generation. You have to be thinking in systems and not just single components, because you have to basically improve or iterate on everything all, not necessarily all at once, but all together, right? So you need to be scaling your ability to improve everything in lockstep, because if you just improve one part of the robot, then you'll find the next failure point is somewhere else in that system chain. So that's what I thought was really interesting when I first learned about this, was that you were thinking of that whole ecosystem.
yeah,
How do we improve or speed up iterations and development?
yeah, and so in that regard, and then I think I'll have a demo at the end. But in that regard, there are kind of four components I looked at, and all these 10 things can be kind of bucketed into these four components. One is that understanding the robot at its core, what you've already built, and maybe you haven't built the thing yet, but you want to understand maybe capabilities, those kinds of things. So that's kind of the robot discovery. We're looking at the CAD models. We're looking at all of your documentation. What operating system are you be working on? What we're going to be working on an NVIDIA device or something else. And then we help you like really, really lock down your control code. And some of that's using generative AI to help. So it's taking your code, saying is it optimized for this kind of situation, as well as looking at physical hardware itself to see if there's going to be some pitfalls in some things that you might do. And I'll give an example. Most robots or robotic companies just choose a camera kind of willy-nilly. They just say, oh, well, I have a RealSense, or I have this camera, whatever it is, right? Owl, or, I don't want to leave anybody out, Z2, whatever it is, right?
Mm-hmm.
I have a camera, but that's not the story. The story is you wanted to do a thing. So,
Mm-hmm.
In a way, starting with these hardware components sometimes causes you grief later on. And we try to head that off by building up a virtual environment with all of your system in it, all of your motors, your sensors, your cameras, everything, and then kind of let you know what things are going to be compatible, camera placement, if we're going to stay on the subject of camera for a second. And most people build a robot, they put their camera where they think it might go. Well, there's an optimized position for a camera, depending on what you're trying to do. And so we'll help you with even camera angles and getting your specs of your camera to align with your needs. So that's just one example. So that's robot discovery.
Cameras is a good one. I come from a computer vision background. Do you find that often that like a company will, for example, like you said, you're like, oh, okay, we know we need a stereo camera. So maybe they have experience using a specific camera or a specific manufacturer. And so they just go plop one on. Do you find that most companies don't go back and think about that until they're much further down the road? Is there importance of, let's say, like really early on figuring out at least the best initial starting point for your sensors?
I'll tell you, this is the way I feel about this is you start with your robot where you have the most knowledge, typically. And I might have said this online, but I think robotic companies are a bit diluted in talent. Not that they won't all come up to the same place, but 5 years ago we weren't talking about robotics, and I think maybe myself and 30 other people were talking about humanoids, and we used to all meet together and talk about humanoids, and there was nobody else. So there's no way that we can get to this place where every company has all the talent that they need to do a thing. And so you start where you're comfortable. Some people start with the simulator. Some people start with the hardware design. But certainly you're not going to have a camera expert at the same time that you have a simulation expert at the same time you have, all the different personas that it takes to deploy a robot.
Good. That's a good point, right? And also, there's a lot of you just don't know what you don't know until you've at least built your MVP, right? Let's put this out in the world or start collecting some at least simulation data. And then you might decide you have the wrong setup.
Yeah, and even then, I think actually, to tell you the truth, I've seen stuff go to production not fully understanding what they built and what the ramifications were going to be for what they built. And then you have to plan around the thing that you have, which is really not the way you want to operate.
Mm-hmm. I have heard Sunday Robotics. They were talking about just their gripper and how that they went through they had like 5 versions, and within each version they had 20 different sub changes, and so they went through 100 different changes of their hardware before they got to where they liked their gripper. Just to show you how they thought they kind of had a good setup initially, but how many different variations you need to test to be able to get to an optimal end result.
Most
and
definitely. I'm sorry, I was
you can
cutting
do
you
that in a really short amount of time. So the quicker you can go through those iterations and know like what's working, what's not, the better for you, right?
Yeah, the issue with that is the iteration cycle for robotics is disconnected. You have a mechanical engineer who's working on the CAD system. You have software engineers working over here. You have electrical engineers, computer engineers, whatever it might be, simulation experts, designers. They're all working in different places. The robot itself, even in those versioning, is nearly impossible to keep straight. I think NVIDIA is doing a good job. They're building a lot of like connectors and components to other software. But reality is there's not a clear path from, idea on the whiteboard all the way through to production robot where it all stays connected. And I think, that's kind of what I'm trying to do.
Well, so then do you want to get back to your 10 things? I could probably ask questions all day long, and I want to make sure we get through this because I think this is really interesting. And to be honest, I did see a lot of robotics companies at CES, and yours was by far one of the most unique I saw because you're tackling something that I didn't see a lot of other people either tackling or talking about, you could say.
Yeah, I think what people are doing right now is they're building a robot. And building a robot is hard, like I said before. But in building a robot, they're not thinking about, okay, what's the use case? How is it going to be usable? I've seen more robots song and dance, do martial arts and drumline than I have seen actually pick up things of value and do something with it. I was very impressed with, say, LG that I saw. I was definitely impressed with Boston Dynamics. I always am. But the majority of companies you see, they just built a robot. It really does nothing. It's a teleoperation device for now. And they're thinking about software later. And unfortunately, that's the reverse because the thing that you want it to do will determine the hardware, which will determine the software. And then all of it needs to be built together and iterated on together. You'll find that, or at least I've found that companies fail the most. And I come from an area where we help startups at Amazon. It's startups in robotics. Where they fail the most is they think, aha, I have an idea, and they build that thing. And then they try to put it into production. They find out it doesn't scale. Half the things that you've used in your POC don't scale themselves. Like the motors, you can't find the motors. You didn't do cycle testing on the motors to find out that the motors last just 5,000 cycles and they die. Right. So these kinds of things, I feel like somebody has to think about them today and not wait for tomorrow. And I can give you long-winded answers, but I'll just keep it there.
Okay. All right. Well, that is. I think that's one reason why companies like Boston Dynamics has been, is much further ahead. For one, they've been around longer, but they've learned those challenges, right? They've cycle tested their robots. They know they should at this point know all those things because they're not a small startup. They've learned those painful lessons over time.
I'm super excited about this, obviously, but if you measure, the companies that have been around a long time and their success in robotics and versus what's happening today, you have a proliferation of companies that are just coming out of nowhere and they built a robot and that's super cool, but it's not something that can go to production for the most part. And certainly, we haven't put them out anywhere to see where the system is going to break. And I don't want to mention any particulars, but if you're thinking that you're going to put a humanoid into a home in the next year, other than in a test cycle, you kind of way off. Like this is no way on earth that a humanoid should be in a home in the next year, given that we haven't collected enough data about how, especially something with legs, is going to function over time.
Mm-hmm. So if let's say put myself on one of these lists to get an early humanoid robot in my home, I should only be thinking of it as this is a test unit and it will fail or it will run into lots of issues. I'm here to help get over that gap, but I'm not here to just get a robot and it's going to deploy and everything's just going to go well and I do everything I wanted to.
Completely agree with that statement. And actually, I will buy one too. You know,
Right.
I build robots, but I will buy one. I have a robotic lawnmower that I didn't build, and I definitely have the vacuum cleaners and those kinds of things that I didn't build. I will buy it, and because I want to help the whole community be better. But I also won't let that robot be anywhere near my children. I have a toddler, and if the robot actuator misfires and falls, it's still 100-pound thing landing on my toddler, right?
Yeah.
So, but
I think a lot of people forget that some of these humanoids weigh as much as a human, right?
yeah,
Some of these are easily 160 pounds.
yeah, and it's a little bit scary. I don't know if you were at CES and I saw a lot of robots just kind of randomly walking around, and I don't want to single anybody out, so I'm not going to say the names, but I've also seen those same robots fall on their face and break things, and I don't think those are ready for people yet, unless you're going to install a gantry in your home and you're going to have this big tether, hanging off the robot to keep it from falling. I don't think we're going to do that. So,
Yep.
Anyway,
if you go buy Unitree G1, they're like the most popular robot I think they have. It's like you go to the shopping page and they have like the 4 models and a gantry. They know
okay,
you don't want that thing just walking around, at least until you really know you've got it trained. So,
no, absolutely, 100%. Um, yeah, no, and even the G1, even when you have it trained, there are things that still happen. I think we have a hardware issue also, where as a human, we have redundancy. You have fibers, muscle fibers so if one muscle fiber is off, the rest of them still work. So you just don't fall, like a robot has one actuator fail, and now the entire system's messed up, and now the robot's flailing around wildly, and even a Unitree G1 can hurt someone.
mm-hmm. Yep, definitely. I mean, they're boxing now. And you said we have redundancies. I mean, I could even break my leg and still be able to hobble on one leg.
Yeah,
I know how to do that, right? Like if a leg completely fails to balance on one leg and get itself to a safe place. I don't know about that yet.
yeah, we're made for that, and I think at the end I want to show you a demo, but we're humans. We're made for these kinds of issues. A robot isn't made for those things, and more than that, we're not putting software on the robot that thinks of what conditions are supposed to be normal and maybe shutting things down when they're not. Every time I see a flailing robot online, I cringe a little bit, because the software engineer in me would make sure that that's not possible.
Mm-hmm.
The hardware engineer in me would make sure it's not possible. I was just having a conversation yesterday with a person who's kind of famous in mechanical engineering, and we were trying to talk about how we can coordinate so that the hardware, locally has redundancy. Meaning, like in my actuator, it knows that if I received, go to this position, and then in the very next instance I receive another go to an opposite position, and they're in rapid succession, then let me gracefully shut myself down. Because that means that you're doing this, right? You're flailing around, and you don't want to be. And so that needs to be in the actuator itself, so that the signal doesn't have to go all the way back to the single board computer, the Jetson Thor, or whatever it might be, and then come all the way back, because it may not. Like you might be in an infinite cycle of bad communication where, you maybe sent a command, it interpreted it 100 times when it was only supposed to do it once. And that's a problem.
Mhm. Yep. Yeah. That's a danger, a dangerous, even in a warehouse where there might not be danger to a human, you might break some equipment or, cause some real issues.
My favorite example is for myself. I was testing a robot. It's not a famous one, but it's one that has come out recently, and we purchased one. I was testing it, and it kind of started walking, and then I went to make it stop walking, and the last command it got was to just keep walking. It never interpreted the next command. It got stuck in a loop. It happens with software, right?
Mhm.
And we had a window, and this is a high-story floor. And so I had literally had to tackle this robot from running into the window and breaking it and falling down. I can't even tell you how many flights of stairs onto a person or people.
Mhm.
So these are things that we need to be able to control with software at the very onset. And now I typically defensively program everything that I do. If if you, and then I'll give you an example. If the robot hasn't heard a command from you in a certain amount of time, it's basically the heartbeat, I'd stop the robot because I would rather it, wait a little bit or think a little bit more than make a mistake.
Think slow, right?
Oh yeah.
And this just gives me pause to think that, like Disney's looking at robotics. Think companies like that who are eventually wanted to place in a theme park. They must be thinking safety first as well, and thinking like, where's all the places this thing could fail safely? It's probably going to be a long time then before you would have one of those humanoid robots in a Disney theme park anywhere near a human. If anything, it would be in a poor enough area where people can see from a distance, right?
Yeah. Yeah, if you saw that, Disney, the little, I don't know the name of the little robot they had that walks on two legs.
Yeah. A
Uh,
little, I think they announced Olaf, their
Olaf.
snowman.
Yeah. So the one thing they did I thought was really cool is they're calculating the safe fall position.
Mm-hmm.
Like, so every movement of the robot, and actually I added that to my software because I thought it was a great, neat thing to do. Yes, it takes compute, but the reality is, if you're going to be operating around people, you should always be thinking about what's the safe action that I can take if there's a problem. I always show. I have a picture of my now 2-year-old daughter. This time she was 1, and I show her a picture of her sitting on top of a Boston Dynamics spot that was in my home. As a matter of fact, just sitting on the floor over there. I show this picture to people because I had to remind people that these things are very they're very powerful, first of all, and children have no clue how dangerous these things might be. My daughter thought it was like our dog, and she can just jump on its back.
Mm-hmm.
So I ended up writing some code that says if you see or hear my daughter or a child, just sit down and turn yourself off before that thing gets close to you, a person or thing or whatever it might be gets close to you. And the reason why, yeah,
That's a great idea.
no, it's a great idea. It's not a good idea. I think we don't have it right now. One day, robots are going to be like the Jetsons, and they're going to be able to operate right next to us. But until that moment, we have to be thinking about, who is operating near the robot? Are they potentially going to do something unsafe? You can lose a finger easily by putting your hand near an actuator. There's been cases where the robots just kind of turned off and broken someone's foot. These are things that we have to think about in advance. Who's my user? Are they prone to do something, erratic that we wouldn't expect? And then how should I respond?
Mm-hmm.
Yeah.
That makes sense. Well, I would love to keep talking about safety, but I know you have lots of other things to show about what you're building.
Yeah.
And
Go ahead.
so, but you're thinking, first thing you mentioned was, we discover the robot, right? I remember you talked about how you had the robot move all of its arms, its, different systems around to learn the bounds of the, its movement. I don't know the right terms exactly.
Yeah,
right? But you want to make sure it's like does like a little crazy dance almost and says,
yeah,
okay, well, we now know what the bounds of what the motors can do, where they can move.
yeah. Let me
Um,
explain that. So,
yeah.
yeah. So typically, even before you have a robot, you want to just make sure that you understand its range of motion, how it can move, what speed it's going to move at, those kinds of things. There's a lot of different thinking on how to do that, but I'm going to show you a video, and this might illuminate this just a little bit.
Okay.
Uh,
And I just for anyone listening on, I'm going to remind you. I said at the start of the opener, just make sure that jump on the YouTube version of this podcast if you want to see the videos and the visuals.
Okay. What you're seeing here is this is an open arm robot, and what it's doing is it's going to eventually spawn thousands of these same robots, and it's going to go through and do every motion that it thinks it's capable of.
Mhm.
Uh, it's going to do this in simulation first, and then we plug in the actual robot, and then we do essentially a true up of how did it actually move when given these commands. The idea here is in simulation, the robot works perfectly always.
Mhm.
There's no bounciness. There's no play in the actuators. Those kinds of things. We can obviously use algorithms to kind of simulate that, and I do that all the time. But the reality is, there's nothing better than the actual robot. We start in simulation, and so that we can get a baseline for joint limits or collisions, those kinds of things. How the robot's supposed to be able to move, like what its coordinate space, or they call it joint space. Have you ever heard that term? And that really literally means like how much space can I take up if I move, you know,
Mhm.
my joints. And then there's also something called a Cartesian space, which is this is every micro dot of where my robot can end up in space. And you train that kind of corpus of information, and it develops an algorithm back that now we can use to help us build up a policy. So that was a little bit complicated, but the reality is, just like a baby, we flail the arms around in the legs and we let it explore, and it
Mhm.
comes up with its own idea about how it can get to locations and the speed in which it can do it.
And so you would run this on sim, and then you plug in the real robot. You would explain this to me. You can have identical models of a robot, but there's slight differences in how it was built, even resistance within the motors.
Yeah, and that's why I kind of have a four part thinking on these things. There's this robot discovery, which is that let's figure out what the robot can do. You know,
Mhm.
it's in simulator, and then fast forward along, and we'll talk about the other parts, and I'll show a demo of the other parts. But there's also this like robot deployment where we have now the models are trained. We tested on a singular robot. It's gone to production. Over time, the stats on that particular robot, or even at build time, the robot is not going to be the same as another robot.
Mhm.
And there's no two robots that are going to be identical. And I think we're going to see that at scale, the more robots start to come into our lives. If you try to run one model for all those robots, you'll find that they're not going to perform the same, and it'll introduce micro I call it micro abrasions into the robot, where the robot can't get to a location in the same defined amount of time, so it introduces a little bit of backlash, and that
Mhm.
backlash turns into more backlash, which turns into a bearing weakening, or a motor not being able to perform as it used to before. And those micro abrasions become big issues as far as your robot being safe. So what we want to do is, in that deployment cycle, we're always looking at the particular robot, the individual robot, what's happened to it, how it's responding to the input stimulus that you're giving it. If it fell, if the robot's fallen before, then it's going to reduce the cycle time. We got to look into that, like plan maintenance for those things. I'd love to be able to say that, hey, you've used this actuator to its cycle time length. You've
Mhm.
used it 10,000 times. You need to at least check it, take it off, make sure it's still in operating condition. I'd love to be able to say that for each individual robot.
It's like my car. I have
Yeah.
a newer car. I had a prior to that. I had a quite old car. Had no like had a very little amount of electronics, and so I'm getting used to the car now saying, "Oh, your tire pressure is low," which is not quite what we're talking about. But now it's even saying, "Okay, you've ran the motor long enough. You need to go take it in for maintenance." It's one of those plug-in hybrids, so I never knew how long to go in before because I'm not using oil when I'm running on just the electric motor. And then the guy's like, "Oh, the car will tell you when you've ran your motor enough cycles that it needs to come in for an oil change." Like, oh, I love that. It's telling you, right? And so the software is monitoring the how many miles it drove with the motor on, things like
Yeah.
that. So that's what we're seeing here, right? It's like you don't want to rely on someone to saying, okay, it's been out deployed for 3 months. Maybe we should do some maintenance on it.
Most definitely not. Especially some of these things are going to be thousands, hundreds of thousands of dollars. So,
Mhm.
and then the ramifications of failure could be safety issues. And so that's another thing we're looking into is safety and certification. We're going to be partnered with another company working on that. And the idea is we will provide all the data that it takes to keep your robot safe and humans safe from your robot, because we have to be kind of very prescriptive as to plan maintenance. These are a little bit boring topics for robotic engineers. Nobody wants to hear about that, but they're important nonetheless. If you're
Mhm.
you know, and that's why they say if if we're building robots at this stage, but we're not designing the software to go with those robots. And that's why I endeavor to be the Android OS or SDK or JDK in that case
Mhm.
um, for robotics, because there are very few companies that can think about this and also build that robot today. I think of maybe three that I think will be successful at doing all of that, and that's simply because they have the staff. When you have a couple hundred engineers, then you can do that. But if you have 10 engineers, you can't do that.
Yeah, that makes sense. That makes sense. You need it takes a lot of people to deploy these things, more than just a few people building and saying, okay, ship it, right? It's all those downstream, like you said, probably the boring thing to a mechanical engineer is probably maybe one of the more critical things when it comes to actually deploying.
Yeah, and then there's the like thinking about longevity of the robot, but also being able to continuously deploy and improve upon that robot. Like when you push something into production, it's not fire and forget and you're done. It's typically you find that there's the packages need to be updated. There are advancements that happen, and particularly one of the things that I'll show in my demo is the comparison between a model that might be running on your robot in production versus one that we've just built out. So let's just say NVIDIA comes out with Groot in 5.7 and you're still on 1.6. You'll probably not like that. You'll probably want your robot to be up to date using the latest available models, to do the job that you're going to do. It's probably going to be more efficient. It's probably going to be faster. It's probably going to be more reliable. So what we do is in simulation, we take a look at your whole robot and say, it's running this. If we upgrade to this, we will do all the simulation testing and then give you back analysis and this is all running in the cloud, by the way. So when I say we, all of this software is running in the cloud on its own. It doesn't require me at all in order to run. It will just run and give you back reports.
Okay. Oh, that's great. So it has an autonomous component. That way you're not at the whims of you being there physically remembering to test things and
No, you never want me there. And let me show one last thing. And I will have the live demo to show you later on. But this is I think I showed you this one. This is using your light wheel asset. So I thought this is like
oh yeah.
a worthy demo to show. Light wheel has this asset. It's a deformable body orange, which means the orange is squishy and physically accurate. And here's a robot that is running Groot. And so same robot in simulation is running Groot. It has never seen this orange asset. It's just been spawned, and so it has no idea what it's supposed to do with it other than try to pick it up. That's the task it's been given. So you'll see that it goes to pick up the orange, and its gripper states or basically open and close. It doesn't do anything besides open and close. So if I just open and close on this orange, what's going to happen? Bam. The orange squeezes out and juice flies everywhere, right?
Mhm.
Orange hits the floor. It's a terrible situation. What I do is I feed that failure back into Groot and other things, other models, Pi 0.5 or whatever you might be using. And I say, this is what happened with analytics, so that it's doing some reasoning. And at that point, the very next time that it executes a thing, it now knows I can't squeeze this thing so hard because, it's just going to, pop out of my hand. Let me think about another way of doing this. And eventually, and so this is simulated restarts with the new information, and you'll see that it's able to pick up the orange. And in some cases, like I really want to get my hands on your bag of orange assets because I think my software will work for that. But
Yeah, I'll make sure I put that on the screen as well. The plastic deformable bag with a bunch of oranges in it. Yep.
yeah, give me that asset because I'm 100% that I can pick it up. Because here's the thing: I think you need two hands. Number one, the other thing is as you can see in the second, and this is I like to show things at 1x speed. I can't stand when people don't do
Oh,
that.
and they will trick you. I'll see things that'll say it'll be like 1x and also say 2, then 10, then 2, then they like speed ramp
Yeah,
to
no,
make
no.
it look smooth.
So now this is using Gemini Robotics ER 1.5 model. And what it's doing is it says, okay, and as a reasoning model also on top of that. So it stopped and it reasoned, it thought, and it's like, okay, wait a minute, you grabbed it this way and it didn't work. Why don't you try grabbing it another way? And then you'll see that now instead of that just coming and grab it from the bottom, it's coming in from the top. I don't know why it needed to do that, but you'll see that the gripper doesn't do that like ridiculous, crazy squeeze anymore in that same location. So even though this gripper is now, it's still an open and closed gripper. Um, it now it's grabbing it from a different location where it's going to be more successful doing that same operation. So this is the kind of stuff. And by the way, when that's done, and if it's successful a certain amount of times, it saves that as an episode or several episodes, and then passes that back to Groot or whatever model you started with for fine tuning. So that now those pieces of data are now available to fine tune your model and then redeploy your model. So when we're talking about the thing going to production, now the thing that goes to production is constantly being tuned. My time at Amazon has helped me. You can see it. Tried to close, and it was like, wait a minute, we did the same thing last time. Now I'm going to close on the center, and now I'll be able to pick the thing up. So, so you can see. Oh, and I was going to say, this is one point. My time at Amazon really illuminated one point about robotics, and that we have to be thinking about the continuous deployment cycle, right? How do we continuously update our robots, both hardware, software, plan maintenance, corrective action, predictive maintenance? All of those things I think are essential in robotics. So I'll stop it there. But these are the kind of things that I think we have to be thinking about in the world of robotics.
Back to this orange slice. You said you created an episode. I myself want to be self-admit that I'm still learning about how you're training some of these foundation models, some of these like Reese says, like Groot. I want to fine tune it. Are you feeding it just the success? Is that the episode is just the success, or are you feeding it the whole chain of it, figuring it out?
No, yes, you can't just use successes because then it won't be able to recognize corrective action. So there's no magic to this number, but certain models are better when you feed it a certain amount of just noise data or failures. Certain models are better at that. So what I tend to do is I try to feed it 80% successes, 20% failures with corrective action. In some of those failures are catastrophic failures. So you've tried to pick up the orange, and as a matter of fact, I think in here I have an example of that where it tried to pick up the orange and it failed, and I still record that because the way it tried to pick up the orange was useful. As you can see, it failed there when it picked it up at the very top. It is useful to know that, don't try to pick it up from this spot.
Okay.
So I think that's and so there's a quality score that goes along with episode recording. I don't just flat out ignore the failures, but I think of the failures as if it's a learning opportunity, then I add it to the corpus of data.
Okay. Okay, that does actually help me a lot understanding this, and I've even gotten that question from other people who are kind of on the learning journey with me as well on, training, I think a foundation model or a VLA, and they're saying, oh wow, if you're just doing teleops and you're just nailing it every time, how's it learning from failure? And
Yeah.
like that is a good question. I'm pretty sure that also teleops also doesn't do 100% success.
No, and then teleoperation has a lot of noise in the data too, because if you've done something a whole lot teleoperating, then get really good at it. But if it's your first time, and I've had people teleop devices that I have for the first time, and you can see them kind of trying to figure it out. I have one where you kind of, this is not the one I'm speaking of, but I'll just show it. So this is the designer of this particular robot arm. His name is Rob Knight. And he's doing something that's called mirroring, which is the robot's looking at him through basically a media pipe, so a camera, and it's looking at where his joints are. This you could probably do on very first look, but if you tried to pick something up while mirroring, you might struggle with that, right?
Yeah.
If you're trying to like show the robot how to pick something up, and you're just using your hands in space, you might not be able to do the thing. But eventually, you'll get to the point where you're really good at it. And so we want a little bit of that not so good data, but we want mostly where you're kind of good at stuff or you failed. Those are the two cases that we really want, because if you're kind of good at stuff, then the robot becomes very efficient. And if you fail, then the robot has to do corrective action. So those are the kind of states that we want to be in.
Okay. No, that definitely makes sense.
Yeah.
Well, for sake of time too, I want to make sure we get through all the rest of your 10 things.
Yeah. Let's
simulation and robot discovery. Well, you had a lot. You did talk about safety systems.
Yeah.
What do you want to move next?
Yeah, these are the 10 things on the page. So this will make it very, very simple. We are focused on a few things. Modular hardware design. That's why I have mechanical engineers. We do here, and yes, I'm selling a platform as a service, but the reality is if you use certain bits of hardware, you're going to be deploy faster than if you use something that's never been seen before.
Mm-hmm.
And so there are things that we're supporting out of the box. Like if you decide you want to use a single board computer, I'll probably recommend a Jetson Thor or an Orin or something like that we're very, very familiar with. And then that once we've got that hardware out of the way, what we're going to do is help you generate control logic. So think about, let's say I have, you like cameras. So I have a Luxonis Oak D Pro camera, for instance. We are constantly monitoring those repos for those particular, those cameras and those things using generative AI. So what we're doing is saying, all right, is there an update for this particular thing? Let me check the repo on a regular basis for an update. If we know that camera's being used somewhere, let's check for control code. Let's generate control code if necessary for a particular system, or kind of use stable known good code. And so this is if you're into code generation, which I am, you probably looked at my YouTube channel. It is really the one of the basis for this entire stack is the fact that you can generate code for a particular situation, and then I can generate that code in a way that it's in a virtual environment that matches your robot exactly. So if you're on Ubuntu 24.04 point blah 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 blah, that particular version that you're on, all of the control code that's built up, all the sensors, all the motors and actuators, all the things run in your virtual environment. They're tested in your virtual environment. We go through critic loop and creating test cases. All that stuff is being generated for you in that environment. You get documentation out, and you also get control code out. Why that's useful is we can take that direct code, use that in not only the simulator, but back on the actual robot to run your robot right away. I do a demo where I haven't done this one in a while, but it's like a bring your own device demo. If I can connect it to my hardware, I can make your whatever device work without writing a line of code. All I need to do is know that the device is connected and take an actual picture of the device itself to get some understanding of what it is. And then I stop. And the control code loop writes itself. It is something, it's very, very experimental, but it kind of makes the point that I'm trying to make here.
Yeah.
Yeah. So then there's, I'm going to skip over safety and privacy for a minute. This whole idea of robot discovery is what we've been talking about so far. And that's like a robot, figuring out what the robot can do, building up what we call a contract. When that basically means we know the robot is capable of these things. This is how it's capable of these things. These are the APIs that you can connect with in order to make it do those things. And so that's all being built by the system. There's not a person involved in this unless there is an intervention that needs to be. But you get basically a set of assets back from that says, here's the control code for your robot. If you remote into your robot, you can deploy it. We can also help you deploy your code using software as well. And just to keep going down to 10 things, unless you have questions.
No. So far, this is I'm sure the people listening might have questions, but this makes sense to me. I like the generative AI, because it's also speed, right? You're not, hey, we're going to work with 10 things, and then there's software engineer who's got to go write a bunch of code and do a bunch of, this is all about speed or iterations.
Yeah, it's also about your personalization and your keeping of your own IP. Mm-hmm. So you may not want me to have access to your CAD model. You may not want me to have access to the software you wrote or your particular model you want to use. It's really about you building up your own environment. Essentially, you sign up to work with 10 things. You get access to a virtual environment. It's sitting in the cloud somewhere on a box, and then everything that we're talking about here is there. So you start uploading your docs, your models, whatever it might be. It'll start discovering your robot for you. If you have control code, you can link to it, and it'll just use your control code, looking for the contract that it needs. And what I mean by contract is this big, giant document that spits out after robot discovery is over, that says this is what your robot's capable of, and this is how I'm going to do things. Once that is done, then you're into this mode of simulation, discovering what what models work on best on your robot. That's all you. And you'll see when we do the demo, I think we're going to do a post demo, right? You'll see how that works. The flow of operation, it should be, for the most part, seamless. What we're doing is we're testing this with multiple companies and multiple robots to make sure that we've covered all of our bases, because having built this for 3 or 4 robots, that's not good enough. You need to look at the entirety of the use cases that might come along, and all the edge cases to say what can you support and what can't you. And then these different ways of interacting with your robot. If you look at multimodal for a minute, really that's how can I utilize this robot from a teleoperation perspective, AI driven perspective. Am I going to use handheld controllers to do imitation learning on the robot? I'm going to use my own body. I'm going to use mocap, those kinds of things. So we're looking into all supporting everything that's out there, and obviously there is going to be things that we recommend over other things. So, and I think we talked about continuous learning, so I'll skip past that.
Yeah.
And I want to end on this one part, which is advanced scene understanding, because I think it's close to what Lightwheel plus some other tools are doing. Like I think of like Isaac Lab Arena, when I think of this. And actually, this includes Isaac Lab Arena now as of last week.
And in fact, we co-released that with NVIDIA at Lightwheel. So
Yeah.
yeah,
So
it's hopefully it's a useful tool for people.
what I've done, because I didn't know Isaac Lab Arena was going to exist, is I built basically a scene understanding tool that creates X number of scenes based on your own, the robot's working parameters. So if the robot's going to work in a home, I create, X number of permutations of a home, just using the assets that are available in the asset catalog that I have at the time. So right now I have a couple of thousand assets for a home. Some of them are SEM ready, some are not, meaning that, some of them have physics and those kinds of things that we need. And then the robot is now put into Isaac Sim or Isaac Lab with those assets in the right location ontologically. So basically, like, you think about an apple is in a bowl on a table, and the table's in the corner of the room. Well, those are things that you can use generative AI to figure out where those things belong and suggest places for those.
Okay.
Yeah. So
Yeah.
that's probably the most, if I think of all the software I've written, the most experimental thing that I've done. But the reality is it's probably the most useful. And I think, and certainly Lightwheel and NVIDIA should be thinking about that, because, yes, we can randomize the environment, domain randomization, change lighting conditions, change colors. But the reality is, if we really want the robot to operate with and understand even edge cases, we got to throw everything in the world at it. I kind of learned that from watching how Tesla operates. When they the Tesla car, when it first came out, they had a lot of simulator data, and the more time they drove the car on the road, the more the data converged on road data. So there was a point in time where you see an edge case, the car was so constrained to understanding the road that it didn't understand the edge cases. And in the home, that's 10,000 times the amount of complexity, because the road has rules. We have like understandings, like a human has the right of way, right? The red light, you stop. We have these rules. In a home, you don't have those rules, right?
Right.
Anything under the sun. If you have children, they've done everything.
Yeah. Nothing as random as having a bunch of kids and a dog in a house.
Oh man, the other night I sit down on my couch and there was popcorn in the seats, and then I go to clean the popcorn and there was something wet and cold, and it was a popsicle for my 2-year-old, and then popcorn, right? So I'm thinking, like, a robot has to deal with all these situations. It has to know what's a doll versus what's a baby.
All right, good point. I didn't even think about that. The fact that we have all these things in our house that could be misinterpreted.
Yeah. So, and the way to deal with these situations is to understand what your limitations are. Like, and I gave the example of the baby in my daughter and the Spot robot. Well, I made the Spot sit down whenever it saw my baby. That's a perfect example where if I don't know what the situation is, I think I would rather have the robot stop and call for help than to try to do something. And this is that thing where what I built out is basically a scene understanding tool that takes in every kind of asset that I can find, puts it in its correct location, puts it in incorrect locations, and then has the robot try to move about that environment. And then I want it to create problems. I want it to tell me, hey, I can't move here because this might be you insert whatever, especially in the home. It could be anything. So, and I'd rather a robot tell me I can't do this thing than try to do something and hurt people.
Mm-hmm. That makes sense. I think one of the hardest gaps are going to be for us is when we're going to evaluate is how do we come up with all those edge cases? I talked to someone else and they were saying, well, that's up to the person building the robot to come up with all those edge cases.
No.
But there's no way that we're going to come up with infinite number of edge cases. That person was talking about car simulation, so they know where they've already done really well, right? It's like, okay, we're really good at these edge cases. We saw this one edge case one time. Can we create a bunch of variations on that? Well, so they have some informed somewhat, but like you said, I think the house is so messy. Even warehouses have got some randomization to it that it could be really tough.
Yeah, yeah. At least that's a little bit more controlled. I like to
It
build for
is.
the most difficult situation. But the reason why I built it this way is if you handle the most difficult situations, anything downstream from that will be easier at least.
Mm-hmm.
And so the home is the most difficult. It's the most random. We don't know the things that are in every home. So I've kind of built this system out so that the robot thinks before it acts. And in most routine things, it'll move a lot faster than a new situation. Say, for instance, it's always empty the dishwasher, but my kid put a stuffed animal in the dishwasher. Well, it's a new situation, right? So it might still be able to act, but we were much more careful. Just like a person, when we encounter a new situation, we might be able to just call on previous experiences. But if you can't, then you have to, like I'm teaching one of my kids to drive. So it's all brand new for her. So she has to take baby steps, move a little bit slower. And so that's why I built this kind of unified platform, because it takes in like all of the robot's capabilities. It has this contract of what the robot can do physically, and then adds in this kind of higher level thinking. What should I do? Should I respond to this person? If someone knocks on the door and your robot can open the door, should it open the door? You know, um, you know, if a user of the robot's told the robot to do something, and another person comes in and says do this other thing, which one should it do?
Mm-hmm.
So these things, I've been working on this for the last 10 years, and the reason why I decided to start a company right now, or in last year, is because for me to code all of these things was nearly impossible. I knew I wanted to do like humanoids in dynamic situations. It was nearly impossible, but the reality is now we have generative AI, we have reasoning models, we have the corpus of internet data to pull from, video data, people actually teleoperating the robots. This is all stuff that we have today. And what you can do is build up essentially a brain of the robot. And that brain now is capable of making decisions, determining when it needs to notify, alerting, warning itself, taking, looking at suggested paths and deciding the best path to take. You couldn't do this 10 years ago.
Mm-hmm.
And so that's why I started this today.
I mean, just the power. I've been diving into reasoning models, not action, nothing else, just the chain of thought reasoning, and it's interesting to see how those are really evolving and how that's going to have to be a very critical role. I liked NVIDIA showing their Alpamayo, which is their self-driving car, open source self-driving car, learning framework, and it was saying, a car might recognize an obstruction going out in the middle of the road, be a ball going across the road. Well, in the past, it would just say, okay, stop. Now the ball has gotten past, move. I said, nope, now we have a reasoning model. So the reasoning model might think if a child's ball goes across the street, there's a high probability that the child's going to run out after it. So wait a little longer to make sure there's not something else following that ball. And again, it's like, we'll be seeing that in robots too. So it slows down its reaction, but that's a good thing. Is it time for things to develop in the scene, or I guess you might want it to respond fast if there's a fire or something, but other than that,
Yeah, there's a whole. I mean, we could talk another hour on this, but the reality is like, I firmly believe that we have not gotten to the point where we understand how robots are going to influence the world, or how we're going to be influenced by them. So I err on the side of caution with all of these things. More than just caution, whenever I'm demoing in public, if I'm around the general public, especially with one of the more dynamic robots, I am super safe. I don't want them anywhere near the robot. I don't want the robot near them. If I'm going to operate in a warehouse, similarly, I make the robot slow down when it's nearing people that might be erratic,
Mm-hmm.
but we don't know what how this is going to influence us. I think of this journey we're on right now is like everybody says the Chat GPT moment of robotics. I don't think we're there yet, but I think we're very, very close. And once we start to see robots working in everyone's life on a regular basis, like Chat GPT does or these other models, then we'll know what laws do we need to have for robotics? Like what understanding do we need to have? And just to make one last point about this, if all the robots are different, meaning that they're physically different and the software is different and your interactions are different every time that there's a new robot, we will never be able to come to this like common place where I know that if I tell a robot to do a thing, it's going to do a thing.
Mm-hmm.
You know, it kind of reminds me of when there used to be, I'm a little older than you, but there used to be like a million different kinds of phone operating systems. And then if I opened my phone, it wasn't familiar,
Oh, I remember those days. I do remember those days when I was young, but I had parents that had we had all kinds of different cell phones.
Yeah.
It
So
was like every cell provider had a different operating system. It was not the manufacturer of the phone. It was the cellular networks, right? So you ended up with, and they were all terrible.
yeah, they were all bad. But if you remember those days, or for me, if I get into a car, I go to China a lot, and the cars are very different there. Like opening the doors are different, where the button locations are.
Mm-hmm.
If I get into a vehicle, I expect this kind of contract, and I go back to the word contract because it's how we see the world. We have kind of in the back of our mind come up with a set of norms. And if we're starting to design all these robots, and they're all very, very different, they all act very differently, they all can't enter our lives at the same time without us getting some form of like, multiple personality disorder to accommodate those robots.
Yeah.
And that's why you start to see in like the world of vacuum cleaners, all the robot vacuums are the same. The interfaces are the same, because we come to expect that if I turn this on and I say, go to a room, it goes there, right? And it does the job and it comes back. I think we need that for robotics. There needs to be like, in the Apple ecosystem of robotics, the Android ecosystem of robotics, and not many more. There probably should be no more than 3 or 4 operating systems for robotics that all the different companies ascribe to, because that's what we're going to expect as people. When I go to my job and the robot's cleaning the break room, I want to be able to talk to it in the same way that if I was at home and I'm talking to my robot at home. And I want to have to pull out a manual to be like, okay, how are you going to clean up that spill on the floor that I found?
Yeah. And what I think is interesting, you said an Apple and an Android operating system. There's so many things that are the same between those two as well. So we'll find that there's just the most intuitive way for these things to be operated. And while there might be more than one operating system, there'll be a lot of basically, it's only really one really good way to do things, perhaps. And we might just see that duplicate across all the different operating systems.
100%. There probably will be, and at my company, we're going to try to employ these kind of people, there will be user experience designers at my company, at least. And the kind of people that are thinking like from a psychological perspective, A/B testing on what's best and what's not. And there has to be, if you're going to, I think we oversimplify what it's going to take to bring a robot into your home, into production. And really, if you build the software as an afterthought, what you're going to find is what people are going to have a visceral reaction to that. Like I saw a robot, the user said, this is on like some big show like CNET. User said, get me, I think it was like a bottle of water. And the robot went away for like a minute and a half. It kind of came back with the bottle of water, held it above the lady's head, like, so the lady had to reach up or stand up and get it. And I was thinking to myself, like, okay, this is the interaction. How long are we going to, what's going to take to be generally adopting if the interaction is it takes 2 hours to do the thing that's supposed to be immediate. And then other things are just nearly impossible, like, loading a dishwasher or something like that.
Mm-hmm. Yeah, yeah. And there's one right way to load a dishwasher, in my opinion. So that'll be interesting.
You should be able to
uh,
train your robot. You should be able to train it to do the thing that you.
right, right. You know what? Maybe you do a little bit of I don't know if teleops is right, imitation learning, right? Here, let me show you how I like it to be done, and then it goes into learning mode and then tries to reproduce that.
Yeah, I hope companies do that. I thought I know I think it was Sunday or LG was really focused on that as like an exercise. This is, I mean, I'm a former military person. I like my towels folded a certain way. I know my wife probably she loves living with me, but I like folding them a certain way, and I want my robot to fold the towels a certain way or make hospital corners on the bed the certain way that I
Mhm.
like. And so you should be able to personalize as well. And we're going to get there, right? I think of us like we're at the Roomba generation 1 of robotics right now. That's where
Mhm.
we are.
Gonna get wedged underneath couches left and right. We're gonna have to reset it, and you'll wake up and things are half done, but it'll get better.
Yeah, I think and another play on my company name is I'm building a demonstration robot, one that can operate in the home, and it's only going to do 10 things. Name of my company. And the reason why I say that is I think you can do 10 things well in a home and give the user value that are kind of fire and forget exercises. So you think about your vacuum, you think about your lawnmower, they go do things and you don't care unless something goes wrong. It doesn't interact with you. I think we can do that in the home right now. We can load the dishwasher, we can unload it, we can load the laundry machine, we can unload it, we can fold some laundry, not all of it. We can put things back where they belong. And I can name all those 10 things if you're really interested. But I think that those are that's the start of robotics that needs to be in the home. And then we add new things over time, like we add new skills per se.
Mm-hmm. Yep. Yeah. You just gotta get to the point where it's useful enough for people want to invest in putting one in their house and dealing
Yeah,
with the really learning curves.
I think like people's time is really valuable. And I think if you can replace it, like I think a Jim Fan said this the best. Like I watched a Jim Fan a taping of something, and he said, when I come home and I'm tired, my wife comes home and she's tired, we just want the house put back the way we'd like it to be ideally, and sit down and enjoy a show. But instead, if you have toddlers, popcorn and popsicles are in the seats of the couch, uh, you know. Your dog needs to be let out the back door or into the whatever. It's like all these little micro abrasions. Again, I like that word, like, or the phrase, that cause you this anxiety or stress. And some people like doing chores. I particularly don't. I like things done, but I don't like doing chores. And I also think of like the impact on my wife if I don't do them. So I tend to like to build things to take over the job. Like I don't like mowing the lawn, so certainly we're having a robotic lawnmower. And I don't like putting the toys back after my kids thrown them everywhere.
Yeah, I mean, you're speaking, you're preaching to the choir here because I have 3 kids, and so by the time they're all to bed, and it could be as late as sometimes 9 or 10, and then the house, they help pick up somewhat, but it's never perfect. The last thing I want to do is dishes at 9:30 at night. I just want to read a book or go to bed even. Uh,
Yeah, I want to sit in a clean room. That's
yeah.
the thing.
I, I
Yeah,
think was the selling point of getting a home robot for my wife too. She's like, it doesn't have to do everything. I would just like to be able to go to bed. It work through the middle of the night downstairs. Doesn't even have to be upstairs where we all sleep. And then wake up and everything's been picked up and the counters have been cleaned and maybe vacuumed.
yeah.
And that's it. She's if I come down to a reset downstairs, she would spend a lot of money on that.
I think
So
that's the holy grail, and we're certainly going to get there. It's going to take a while, but my main cautionary note is that we shouldn't rush into, especially the human bipedal humanoids, like the humanoids with legs, because we haven't solved all those problems. Some of those problems are hardware problems, and so we haven't solved those yet. So I really caution that. And the other thing is, we when people or companies show off function that's not actually like they got it to work one time and then they create a video because it worked once. That's not the answer. Like that's the reason why I'm saying that is it gives this false impression to people that right out the gate your robot's gonna come in, it's going to start flipping burgers on your stove, and
Getting
and
gourmet meal cooked the first night, and everything picked up.
yeah, it's going to do that on day one. No, it's not. It and maybe if you can get it to do 10 to 12 things, that's a great start, and we'll add more capability as time goes on as we learn more. And that's my cautionary tale. I know we've gone way over, but I did have to get that part out because I think that companies are really excited about what they've built, and I'm excited for them. But I also know that what they built isn't done. Yeah.
Yeah. Well, for sake of length of this episode, which I mean, like you said, we could go another hour easily. I might have to bring you on a second episode later in the future as you're building this out. But is there anything we missed in the 10 things? And then I do want to have that you have a demo, but self-admitted here, we're having some tech problems, but I will put that in this video so people can watch the live demo after that. But is there anything we missed before we get to that?
Yeah, a bit of my work is very, very solid in production, meaning I have clients already, and from years of doing what I've been doing, and some of it's super experimental. Like if you watch my YouTube channel, I love to play around and try things that I've got experimental code that writes code in experimental fashion that writes research reports. I think I might submit one of my areas of research to IROS next year because it's so experimental and fun. But the reality is like this whole area, I think maybe 3 or 4 companies are trying to build out functionality like this, and there's 400 robotic companies, and only 3 or 4 that are thinking about the future of robotics, how people are going to interact with them, how safely, how they're going to be safe. And I think there should be more. I don't mind some competition. I think it'll definitely make us all better. But we have to think about robotics in terms of, especially in consumer landscape, in terms of this is new. We all need to experiment. We all need to help each other. And then certainly we all need to give back. Like I am very, very passionate about open source. I do contribute to some repos out there like Le Robot and others. Passionate about the community as well. I'm also often sponsoring, students that are, kind of at risk of not being engineers. I'm trying to help them. I often, bring them into the fold and mentor them, those kinds of things. So that's another thing that we're focused on is like giving back to the community, teaching the community, because I think if we're going to have, like Elon Musk says, 1 million robots in 5 years walking around, we're going to need 1 million, not 1 million, but maybe 100,000 technicians that can work on robots. They're not all going to be computer scientists or robotic engineers or researchers. We're going to need people at that level that are going to have to upskill, up level, because the robots might be taking some dangerous, dull, dirty jobs, and we want those people to feel fulfilled and validated. So that's another thing that we're looking into and constantly working on. You might see them on the internet quite a bit, working with kids and youth and that kind of thing, because I think that is the future.
I'm so excited to hear that, because this selfishly as well with me, I want my kids to flourish, obviously, and so I do see robotics as being a big industry, and the earlier you get in on it, like, I mean, obviously you got in way before everyone else, just the more knowledge you can get earlier on. So I'm trying to expose my kids, but I also want to expose the kids in the local schools. I know there's these robotics clubs that do a lot of great learning experience. Learn how to 3D print parts and do the mechanics and program it to do your classical robotics, which I think is a really good foundation for these kids. But none of them are talking about anything beyond like there's no VLAs, there's no one. I don't know any of the schools around here have low robot and training them to do pick and place, training policies. And I see that will be. I feel like classical robotics will still have a place for a long time, especially for automation. But also, I think some of this like imitation learning for a robot is really intuitive to me. I, when it gets down to the math and science, is way beyond me. But I think for a kid to get enamored with robotics and seeing, okay, I'm just going to show it a bunch of operations. I'm going to show it how to pick this up, and then to see it do it on its own, I think is like clicks this like, oh wow, I can do this. And so I'm so excited to hear that you're trying to get this in the kids excited about it because we're gonna need them. We're gonna need a lot of
Yeah.
these kids working on robots, innovating new things, finding that like genius kid who may have never been exposed to robots as and he's in high school, not or she's in high school, not knowing what they want to do in their life, giving that chance.
And you can have any career in robotics. We don't know what the careers are going to be yet because there's so many. I've seen now robotic clothing lines already emerge. Right?
Oh yeah, I saw that as
Yeah,
well.
yeah. So we're
It's
gonna
going to
we're
be
gonna
a
see.
cottage industry.
Yeah, we're gonna see whole industries come out of nowhere. And I'll tell my favorite story. And I hope I'm not embarrassing this young lady, but I was a mentor and advisor to a capstone team in Melbourne, Australia. We did it remote, and I was obviously with Amazon doing this. And the one of the people on the team said to me, she says, "I'm going to build this robot that's going to help with elderly care and memory care, and I'm going to be a CEO one day." And I joked with her because she was just so really bright. I think she was a senior in college, and I said, one day I'm going to be working for you. You're so you're going to have this mega company one day. And I don't know if you know her, but her name is Grace Brown. She is the CEO of Andromeda, and they are worth, I don't know, $100 million right now, and she's 25 years old. And so the point that I'm trying to make with that is if you give people opportunity and you expose them, you might see they might be helping you. Like one day I might need memory care, and I'll have one of her robots, and I'll remember, or maybe hopefully I'll remember that I helped her get her start. Similarly, high school kids, I'm always telling high school kids how. And let me pause that story and just say, in France, they did a lay robot competition or exposed young kids to lay robot, and the SO 101 arm in France. And I was thinking to myself, why don't they do this in the U.S.? Or why isn't it more mainstream here? And then in my travels, they're doing that in Tokyo. They're doing it in China. For whatever reason, we haven't quite caught up or not as excited about robotics as there are in these other countries, but we need to be.
Mhm.
So I kind of paused on the story and I didn't restart it. Apologize.
It's all right.
Yeah.
Yeah, no, that was good advice I got as a parent a few years ago too. As my children are reaching middle school age and they don't know what they want to do in life, obviously, way too early. But now is a good time for me to start exposing them. And they said you can't tell your son or your daughter you need to become an engineer to get a good job. What you can do is you can expose them to engineering things that are interesting, and if they like it, they will go into it. They don't, expose them to something else. You'll find what they're interested in. But if you don't expose them, they don't know what's out there. And right now they're they're in the robot discovery phase. They're learning what's out there. Um,
Yeah, I think at minimum we're gonna need to teach kids about AI in general. They're learning on their own, or at least they're learning how to cheat. So you know. I want them to learn how to get information that they can use, apply somewhere else. Um, certainly, but certainly that's I think that's the future is if you show them, hey, this is how this works. And I always tell this story, and I'll make the briefest story that I'm watching television at 7 years old, and my father comes up to me and says, "How does the television work?" And he said, "Why don't you go turn the TV off and figure out how it works, and then you can watch TV again." And um, I took that as a challenge. I went to the library, which was across the street, pulled out every book that I can find, read everything that I could read, came home with a stack of books, and on my father's workbench was an old TV with a screwdriver and the cathode ray tube taken out so it wouldn't shock me. And it was meant for me to take it apart. So I think that put me on my journey. And I tried that with my kids, it didn't work. But
Take apart the LED TV.
then I started taking everything apart. Like we had a top loaded VCR. I took the VCR apart and I couldn't get it back together all the way. And so the spring loader didn't work, but it still worked. But yeah, I think it's different for every kid, but I just throw all that stuff at all my children. I'm like, hey, try it all.
Yep. Yeah. Yeah. All right. Well, so is there anything else that we can wrap this up? I will put the demo on this at the end. I'll just not say tack it on, but we can record that out of this, outside of this, for people who are interested in seeing 10 things in action. But is there? I think we covered most everything.
Yeah, you got it all. I mean, I have, this is the start of a CEO journey. I don't like to call myself a CEO, because I have like 2 employees now.
You're a founder. There we go. The founder's journey.
Yeah. So it is, there are some things that I don't like to do. Like I definitely hate the business development side of it, and I don't like funding and, or getting those things together. Certainly, I could use some help in all those regards. If I feel like if I help the community, then someone's going to come back and help me. So, sir, if you're watching this and you got to the end, kudos for you. And if you know anything about, those kind of environments and you want to give me a hand, at least in mentoring me, I'm always up for it. Learning things that I don't know. And accepting help from everywhere in the world. So that's another thing to know about 10 things is, we're perpetually learning. This is brand new. So, hopefully, we can help all of robotics be better. And that's if I died alone and penniless, it would be the thing that would give me solace is that I helped move this journey along and bring that Rosie the robot to life.
Yeah, definitely. And I also want to point out that you guys will be hiring as you're growing, but also if people find you, after this, I'll make sure I have links so they can get a hold of you or find your company. You're not although you are a in startup, right? You're new. You have an experience of decades in robotics. So you're not partnering with someone who's just like, oh, we graduated 3 years ago. We had an interesting PhD paper and now we're going to build a company around it. You are taking combined experience of decades of deployment and working in different things. You even have, I'm sure you have lots of experience in the military that we didn't talk about, talking about failure systems, things like that you know, and or how you operate. And so if people work with you, they're aligning with someone who is thinking about the whole system and not just, oh, I wrote this paper, I'm an expert here. Let's build a company that does this one thing that I know really well, but doesn't know much about anything else. That's what PhDs always point out. Hey, I'm really smart, but only in this really small wedge of expertise.
I don't want to say anything negative about any company, but I'll say that you were, first of all, spot on. There's so much that I didn't talk about. I joined the military at 17. And I was in the nuclear field engineering program, which is, it's dangerous, but you learn a whole lot about engineering just there. And there's, engineering operating procedures and those and planned maintenance and all these kinds of things that I've taken with me throughout my entire career. Safety and best practices throughout, being a software architect. And so I can go on for hours and hours. But what I'm trying to do is distill all that into a few pieces of software that are intuitive, and so it is a really monumental task. And so I'm looking for people that think like me, that are thinking about making life easier for robotics. And if you want to join me on this journey, we're in startup mode, so we're cash strapped, but we're certainly enthusiastic, and we'll try to find ways to make it beneficial for whoever joins up. And then I have my eye on some people that I hope, if I will never poach anybody, but if they ever came free, you can bet that they'll be joining me on this journey.
All right. And so With that, then how can people learn more about 10 Things or connect with you?
Yeah, LinkedIn is the best way. Today, I'm fielding tons of. I'm looking at a stack of business cards that I have to get back to people from CES. I probably have like 100 sitting on this desk. But LinkedIn is the best way. I'm fielding all of those requests right now. Pretty soon, we're going to have a head of business operations who's volunteering to come on. But that's the best way to get in touch with me. Certainly follow me on my YouTube channel if you want to see nerdy technical things. And then we'll be putting out videos both in English and other languages showing the entirety of the application working from start to finish over the next month. So we already have a person working on Mandarin translation. And so you should be seeing those in the coming weeks.
Well, with that, then, I just want to thank you for your time. I know we've had you almost for 2 hours here on these calls. But I just want to, again, we'll have the demo. I'll just put at the end of this so you can watch it. I'll let him narrate over that. I probably won't be on that screen capture, but then you can learn, you can see a little bit more what he's got in action. And I just want to thank you, Kimate, for your time. And again, reach out to him or follow follow him on LinkedIn because and YouTube. I'll make sure I link YouTube. It's probably more nerdy than your LinkedIn, but it's good. It's good information, and I think you will find the right tribe, the right people who want to follow that should be there, and they won't find it nerdy.
No.
Yeah.
I was so thankful. I know you're saying bye. I was so thankful at CES that people came by my booth that have just watched my nerdy YouTube videos, and they were just like, I just wanted to meet you because I love what you do on your content, and it's inspiring, and that does a lot for me.
I want to say huge thanks to Kimate for joining us and walking us through 10 Things and his founder's journey. As promised, I'm going to link the demo for 10 Things in Action in the show notes so you can watch this at your pace. There's a few other videos he also has linked on his YouTube channel that you might find very interesting as he's constantly putting out new information. Thanks for listening to the Thinking Machine podcast, and be sure to follow us on your favorite platform as we continue to explore the future of robotics. Until next time.